Hello, today we are going to learn about exponential functions. So go down to this unit, exponential functions, click on this, okay, so click on this assignment right here, and which you probably already have if you're watching this video. So there's the instructional video right there. Make sure you download this document for translations to translate your document. Make sure you hit download right here, and then you'll open it up down here so you can translate those and understand what I'm saying, okay? Okay, so the first questions we're going to look at are questions 1 through 4, basically 1 through 2. So you're going to go ahead and see two tables like that. Okay, basically we're looking at this right here. Make sure you do the translations so you understand what these questions are asking. But the first step in solving is to see how the values change in the second column as the first column changes. So we look over here and let's look at this one here. So first table A, right? So how is it changing? Okay, this goes up by +1, and then from 1 to 2, +1. So every time this goes up by +1. How is this one changing? So here, 10 to 30, we can go 30 minus 10 equals 20, or 10 plus 20 equals 30. But we have to see if it continues. So the next one is 90. So does this pattern continue? So we go, what is 30 plus 20 equals 50? But this is 90, so that's not the same. So it's not going up by plus 20. So let's look at multiplication then. Let me go ahead and clear this out. So then I try to see if it's multiplication. So, okay, so please read these steps right here in your language. Make sure you translate it, and then I'll show you how it works. Okay, so we've already seen that this is not plus 20 plus 20. That pattern does not continue. So now what we're going to do is I'm going to take this 30, like this, delete. Okay, and then we get 30 divided by 10 is 3. So that would mean that I would have to take 10 and multiply it by 3 to get 30, which works here, right? So I get that, so that's good. And then I would take 30 times 3 equals 90, which works there, so it does work, okay? And then I go 90 times 3 equals 270, so it works there, and it continues. So what that means is I have to multiply these values by the same number times 3 every single time, and that is, when you multiply, that is exponential. So the first one, table A, is exponential. Now let's check table B. Let's see what's happening here. So here we can try addition. So 40 minus 10 equals 30. So that means that 10 plus 30 equals 40. So let's see if that pattern continues. So we know it works here. So this is plus 30. So then 40 to 70. Does that work? Does 40 plus 30 equals 70? It does, yes. So that means it works there. Plus 30. And then from here to here, plus 30. Here to here, plus 30. If I want to check, I could go 130 minus 100. So that means with adding every single time, that would be linear, okay? Okay, so that means that, see if this works. Are we working? Is our pen working? Pen's not working. So that means it's linear if you add every time. So exponential is multiplication. So here, this one was times 3 times 3 times 3. So that's exponential. Here it was plus 30 plus 30. So that is linear. Okay, so that's what determines it. Okay, so now in your assignment, you have questions 3 and 4. They're the same type of questions. So check these here to see if you can figure out if they're linear or exponential. Do both tables. That'll be something you can do next. Okay, so the next question you see is questions 5 through 10, where you're going to get this table. All questions, all 5 through 10, are based upon this table right here. So let's make sure that you understand that. Please read this right here. You can also read the question stems, okay? So this is questions 5 through 10. So questions 5 through 10, okay. All right, so first we've got a table here, and it's asking us whether it's a linear or exponential pattern. Well, we just got done doing that. I'll go ahead and try and see what you think, and then I'll go ahead and explain. I'll go ahead and show you how to do it. Okay, first we can try to see if it is linear. Let me go ahead and get a pen here. See if I can get one. So is it linear? Does it increase by addition? So I can go 140, this number here, 140 minus 100, and that equals 40. What does that mean? It means 100 plus 40 equals 140. So from here to here, plus 40. But does that continue? Does a pattern continue? So if I go 140 plus the same 40, that equals 180. Is that what it is? That's one, but it's not 180, it's 196. So it's 196. Okay, so that does not match. So it's not plus 40. So now we're going to try to see if it's multiplication. So I'm going to go that 140. Now I'm going to divide by 100, and that equals 1.4. Okay, so does that would mean that 100 times 1.4 equals 140, correct? That's multiplication times, right? See if my pen can work. Times, okay? Does it continue? Well, let's take 140 times 1.4. What does that equal to? Let's get out a calculator. So that would be 140 times 1.4 equals, that's 196. Does that work? Yes, it works. So that means not plus, but times 1.4 times 1.4, multiplication. From here to here times 1.4. From here to here times 1.4. We can try it one more time just to make sure. So let's see, is the next one 2.274? Let's see, we have 196 times 1.4 equals 274. Yes, close enough. And then we'll try it, okay? So that means that that is the pattern. The pattern, that is exponential. Okay, so that's exponential. And the next thing is, what is the beginning value of the function? The beginning value is the first value. So it's not the first value here, it's the first value for MT, which is this one right here. So that's going to be 100, okay? It's the first value, okay? The next thing that shows up, let's see, is what is the growth factor? Well, the growth factor is what you multiply this value by to get that value, how it's increasing. We already found out that that is 1.4, right? On the previous, when we were working through it. So, okay, so that the answer there is 1.4. It's how 100 times 140 or times 1.4 equals 140. Okay, so now the next questions we have are these right here. What will the money be when time is equal to 6? Now that we know the pattern. Well, keep in mind, we already know, to answer this question, we already know what it is when time is 4, that the money will be 384, and we know how the pattern is increasing. So basically, to get from here to here, let me go ahead and draw. we take this value here, right, the 274, and we multiply it by 1.4, and that gets us to 384. But we need when time is equal to 6, right? So what we're going to do is we're going to take 384, and we're going to multiply it by 1.4 2 times. So let's do it once. Real clear. 280, clear. 384, which again, that's a time right, that's what we have right there. And we're going to go times 1.4 equals, so that's 537. So that would be right here, 537. But we need when it's at time equals 6, right? So we need to do it one more time, times 1.4 equals, and that would be 752 approximately. So now we're going to go ahead and pick the closest one to 752. Let me go to that document with the questions on it. Let's see, I think it's this one. Was it that one? Or it's right here. Oh, there it is. Okay. So 752. So the closest one is this one right here. It was 752.64. So the closest to that is going to be this one right here. Okay, so that's choice A, because these are all very far away. Okay. So the next thing is which function represents a relationship above. Okay. Well, here's the thing. When you have a function, you have this is the form of the function. It's y equals, so y. Okay, so here's your general exponential function. It can be y equals a times b to the power of x. The first number here is always your beginning, where you start, okay? So the b is the growth factor, you know, how it increases, and x is how many times. So if we look at our equation, okay, so let's go back and look at what we already found out about ours. Okay, so it started at 100, correct? So we started at 100. So that's our beginning value. So it's 100 is so we get out. So let's put the generic function y equals a times b to the power of x. So in our case, it's going to be mt, right? So we're going to have mt equals, so the starting is 100, right? That comes from right here, okay? And then the b is the growth factor. Well, we know that that's 1.4, so that's going to be 1.4. And then it's going to be how many times it happens. Well, in this case, that's t for us, so it'd be like that. I'm sorry for the sloppy writing, but that's going to be this one right here. Okay, so that means that we're looking for, again, we're looking for 100 is our starting point, so that maybe this one, yes. This one's 140, so not that one. This one's 1.4, no. This one's 100, but we also need a growth factor of 1.4, so that's going to be, that's not that one, but it's that one. Okay, so our correct answer choice here is going to be D, because it has the beginning of 100, and it has the growth factor of 1.4, which is what we got, okay? So the next kind of problem we have is number 10. Number 10 is a new function, okay? So the function is right here. And what f of 2.5 means, we learned about this before. All we have to do is remember that 2.5 is the input, or that would be x in this case, right here. So that means that f of 2.5 is equal to this function 16 times 1.6 right here, but to the power of 2.5. So now we're going to use a calculator to figure out what that is. All right, so on our calculator, we're going to go to, we have to do, what is it? So we're going to go 16. Okay, so we're going to go 16 and then parenthesis 1.6, 2.5. So this is how you do it on a calculator. You go to 16 parenthesis 1.6 parenthesis. But now to get to the power, we need to use this button right here, to the power of, and it was 2.5. Enter, and that gives us 51.8. So that would be this one right here. Okay, so that's how you do that. So now there's more questions on the next page, so make sure you go ahead and do those, and you'll be done.